Inverse Laplace transform with calculator suggestions. Given the S-domain signal, some S-domain numerator divided by some S-domain denominator, where the denominator is in factored form already, the factors by inspection are s plus 8 and s plus 9 squared plus 7 squared, which means that the poles of f are s equals negative 8 and s equals negative 9 plus and minus 7j. One pair of parentheses can be eliminated for calculator convenience by expanding this term into this one. Recall the inverse Laplace transform factors based on the poles. The real pole at negative 8 yields ae to the negative 8t. The complex conjugate poles at negative 9 plus and minus j7 yields the damped sinusoid. Note the time constant of 1/9 of a second and 7 radians per second frequency. Now calculate A, B, and C. Recall the procedure for calculating A. Multiply by the factor from which that pole came. Note that the s plus 8 factor cancels the same factor in the denominator. Evaluate the pole at the pole, and then store that value into memory A. Recall the procedure for calculating B angle C. Multiply by the factor from which the pole came. Note that the complex factor cancels the same factor in the denominator. Divide by the frequency, 7 radians per second. Evaluate at the pole containing the positive imaginary part. Store into memory D. Then extract B and C from memory D using the absolute and angle functions conveniently found in the math menu. Store in memory B and memory C. Finally, evaluate the time domain function at 1 millisecond. This was our goal, to find the inverse Laplace transform and then evaluate it at 1 millisecond. Graph the function. Enter the exponential function into y1. Enter the damped sinusoid into y2. y3 contains the sum of those two components. Let the window reflect the limits of the function. The plot shows both components plus the sum of the two components. This is the exponential function and the damped sinusoid and the sum of those two components. The final function is evaluated at 1 millisecond. We got 20.1.